Greetings, students. I wanted to discuss the types of motion graphs that you're going to see in your experiments this week. And to help me do that, I've invited a special guest to help us examine these different graphs. Professor Hassenpfeffer from the University of Paris will be joining us today. Say hello, Professor, to the students.
Bonjour, mes amis. That is how you say hello en français.
He's a rabbit.
He's got 3 degrees in physics. He totally checks out.
Well, thank you for your time today. Let's dive right in. Our students are asked to analyze data on a position versus time graph and be able to describe the motion of the object based on the information on the graph. Can you explain a position versus time graph?
Oui, oui. A position versus time graph is motion based on how far an object is from the observer, as seen on the y-axis, and the time it takes an object to move the known distance, seen as the x-axis.
Excellente, Professor.
I would prefer you stick to your weird accent.
Okay. Could you share with us what a graph would look like when an object is moving away from the observer?
Of course. When an object moves away, we see a positive slope. The line rises, showing the distance gained from the observer over time. And the opposite is true when the object travels towards the observer, as seen with a negative slope.
Thank you, Professor. Now can you explain constant motion versus accelerated motion and what that looks like on a graph?
Constant motion results when an object is under balanced forces. All forces acting on the object cancel each other out, resulting in a net force of 0. On a graph, it's represented as a straight or linear line. At every interval, the distance of the object travels is the same. If the speed changes, then the slope is different, and it results in a curved line. You can show slowing down or speeding up.
Well, thank you for your time, Professor Hassenpfeffer. That's a pretty unique name. Where did you get it?
From my Uncle Stu.